Welcome to the Deep Dive. We're here to explore complex topics, really cut through the noise, and help you get genuinely well-informed.
Glad to be here.
Today, we're tackling something right at the forefront of AI. Can machines truly understand things?
It's a huge question.
Yeah, I mean, we see all this impressive output, text, code, images, but is it actual understanding, real intentionality, or is something else going on?
Right, something under the hood, so to speak.
Mhm.
And to really get into it, we'll be drawing from, well, quite a mix. Philosophy, cognitive science, even developmental psychology.
We've got insights from thinkers like Husserl, Brentano, Crane, Daskal, and more recent work from people like Vadinsky, Husserl and McCormack, Largy and Dattery. A lot of it's informed by our source material, including intentionality, context, and the future of AI systems.
It's a rich blend.
Definitely. So our mission today is to help you grasp that difference, the gap between what AI does and what it truly means. Think of it as a shortcut to understanding the really deep challenges in building machines that are actually intelligent.
And we'll touch on why these sophisticated AI systems sometimes hallucinate, generate nonsense.
And, maybe more surprisingly, why we tend to make a specific kind of mistake when we interact with them. Ready to dive in?
Let's do it. So maybe the best place to start is with this concept of intentionality.
Okay.
The philosopher Husserl really nailed this down. He talked about it as the mind's ability to be directed towards something. It's aboutness.
Aboutness.
Okay.
So my thoughts are about my coffee cup, or my belief is about the weather, that kind of thing.
Exactly. Your mental states have content, they refer to something.
Okay, so how does that relate to AI?
Right.
Because like I said, AI performs these complex tasks, finding patterns, making correlations.
Right. It's incredibly good at statistical analysis and pattern recognition. But the question is, does it grasp the aboutness? Does it process information with respect to what that information represents?
Ah, I see. So it can recognize patterns in pixels that make up a cat picture.
But does it understand cat? Does the pattern mean cat to the system itself? Crane really highlighted this point. It's not just about processing, it's about representation of something.
And this isn't just an engineering problem, is it? It's deeper.
Much deeper. It touches on meaning itself, which brings us to the hallucination issue.
Right, the AI generating things that sound plausible but are just wrong.
Oh,
Or nonsensical.
precisely. Husserl argued that meaning requires not just statistical likelihood, but also sense,
Oh.
coherence.
And hallucinations lack that sense. Largy and Dattery talk about this, right? Outputs that fit the pattern statistically but are just, well, garbage in terms of truth or relevance.
Exactly. They might sound right based on the training data, but they don't connect meaningfully to the real world. It really undermines the claim that these systems have genuine intentionality.
It reminds me of what Daskal argued way back in '89, that AI won't get understanding if its symbols don't point to something outside its own internal processing. Hallucinations seem like Exhibit A for that.
Absolutely. It's like the system is just manipulating symbols without grounding them.
Okay, so to dig a bit deeper into intentionality, Brentano and Crane talk about three components, or pillars.
That's right. Presentation, belief, and emotion. It's a useful framework.
Let's break that down. Presentation, that seems like something AI can do, like representing an instruction, bring coffee at 9:30 a.m.
Yes, that's the basic level. The system can take in, store, and represent that piece of information. It's a starting point.
Okay, but then belief, this feels trickier. Can an AI believe it should bring the coffee, or see it as a worthwhile goal?
Well, this is where it gets speculative.
Right.
The source material suggests an AI could maybe be programmed to assign a value to achieving a goal, like completing this task, positive value. You could call that a sort of functional belief in the value of the action.
But it's not like a human belief, with conviction or desire.
No, not in the way we experience it. It's more like following an objective function, a programmed imperative, rather than an internally generated conviction or desire. It's still external, in a way.
Right, and that leads straight into the biggest hurdle, emotion.
The real challenge.
Because even if we program an AI to believe it should get the coffee, it can't explain why it feels it should. There's no internal subjective driver.
Exactly. It lacks that phenomenal quality, that felt motivation, which seems crucial for genuine human-like intentionality. It's following code, not feeling an urge.
So this lack of internal state, this lack of aboutness, ties into another big issue, context.
Absolutely. Current AI systems generally lack the ability to infer context on their own. The interaction feels one-sided.
Meaning comes from us, the users,
Yeah.
not from the AI's awareness of the situation.
Pretty much. It's like that brilliant actor analogy, perfect line delivery, but zero understanding of the play's meaning or the stage setup. It needs the context fed to it.
Okay, so how are engineers trying to tackle this? I've heard about hybrid models,
Yes, that's a key approach right now, trying to approximate intentionality and context awareness by combining different methods.
like symbolic reasoning, direct references, like a knowledge base.
Exactly, directly linking symbols to concepts and combining that with connectionist approaches like neural networks, which learn patterns from distributed data.
So the idea is that intentionality isn't just one thing. It has layers.
That's the thinking.
Right.
Badinsky suggested these dual representation systems help AI refer to things within its defined knowledge domain and also assess if ambiguous data fits those patterns. It gives it more tools, more ways to process information in context.
But it's still an approximation, not true understanding.
It's a step towards it, but yes, still an approximation. For AI to really get closer, it needs more advanced cognitive machinery, reflective mechanisms.
Reflective, meaning it can think about its own thinking or understand why it's doing something.
Sort of, yes. It needs to understand the purpose behind an action and interpret it based on the current situation, not just execute a command.
And this is where philosophy comes back in. Husserl's ideas, Crane's concept of metasemantics.
Precisely. Metasemantics is about how language gets its meaning, how words hook onto the world. Both Husserl's and Crane's ideas point towards designing AI that can infer the intentions and reasons behind external things, not just process data patterns.
And Daskal also pushed for more context implementation.
Strongly, he saw it as essential.
What's interesting is that human context isn't static, right? It emerges from interaction, it changes.
Absolutely. It's dynamic, which means things like ontologies or taxonomies, knowledge structures for AI, shouldn't be rigid prisons.
These should be more like temporary guides, scaffolding for learning.
Exactly. Guides that can adapt as the interaction unfolds.
And this brings us back to generative AI's weakness with context.
Right. Because they often operate independently of real-time situational cues, they produce that nonsense or hallucination Largy and Dattery described.
Like asking for medical advice without knowing anything specific about the patient or the latest research.
A perfect example. The lack of grounding in the immediate context is a major failure point.
So Vadinsky's idea of layered contexts tries to address this, giving AI access to different kinds of processing.
Yes. Symbols, rules, connection is learning the whole toolkit. The idea is to interpret different types of context hierarchically.
And differentiating between semantic meaning and semantic reference.
Good point. Semantic meaning is the general concept dog. Semantic reference is pointing to that specific dog running across the park. AI needs both.
So the layers would go from basic stuff like time and place,
Up to higher levels like understanding intentions, the meaning behind inputs and outputs, maybe even accessing relevant memories or past interactions.
So context isn't just background noise, it's an active input into the AI's interpretation process.
It has to be for deeper understanding.
Okay, this next bit about how we perceive AI is fascinating. We apparently have a tendency to see understanding where there isn't any.
Yes, Largy and Dattery point this out, drawing on cognitive science. We tend to overascribe intentionality. We adopt what's called the intentional stance.
The intentional stance, meaning we assume the AI has beliefs, desires, intentions, just like a person.
Exactly. We interact with it as if it understands. Based purely on its behavior, its output looks intelligent, so we assume intelligence lies behind it.
And that can be problematic, right? It lets people off the hook.
It can, yes. The source suggests it allows users and even engineers to shift blame when things go wrong. Instead of looking at the design or the input, they might say the AI failed or didn't understand.
So we blame the tool instead of the user or the maker, like yelling at your GPS for getting you lost.
Kind of, yeah. It attributes agency where there might only be complex algorithms.
The sources mention 3 ways to explain behavior: physical, intentional, and design stance. And explanation is key to understanding.
Right. The physical stance explains, based on physics, a rock falls because of gravity.
Okay.
The intentional stance, as we said, explains by attributing mental states the chess program wants to win. And the design stance explains, based on purpose and design, the thermostat turns on the heat because it was designed to maintain a certain temperature according to its programming.
So for current AI, the design stance is often the most accurate explanation.
Often, yes. Although its behavior, especially with sophisticated generative models, can make us adopt the intentional stance, the answer sounds so human-like, so responsive.
But that doesn't mean it actually has intentionality.
Correct. Largy and Datteri call it an illusion of understanding. The AI simulates human-like intentional output through pattern generation learned from massive text datasets.
An illusion that can lead to real problems if we mistake it for the real thing. Ethical issues, unintended consequences.
Definitely. Treating it as if it understands when it doesn't is risky.
So looking ahead, how do we build AI that moves beyond illusion? Philosophy seems key.
Indispensable. Insights from thinkers like Crane and Daskal on meaning, reference, and metaphysics within AI are crucial guides for tackling these fundamental drawbacks.
And it's not just philosophy. Psychology offers clues too. Child development, animal cognition.
Yes, particularly work by Husserl and McCormack on how biological systems handle time and context. They suggest AI needs something akin to the dual system found in humans and animals.
A dual system for time, what does that involve?
Two main components seem necessary. First, a system for tracking immediate events and predicting what's likely to happen next in the short term.
Okay, like moment-to-moment awareness.
And second, a system that utilizes long-term memory, background knowledge, and event history to inform present understanding and action.
So it's not just reacting to the present, but interpreting the present through the lens of the past.
Exactly. Humans and animals don't just process time as a linear sequence of causes and effects. We use memory actively. We recall past experiences to make sense of the now.
Like remembering a past mistake influences a current decision.
Precisely. Husserl and McCormack mention episodic memory recalling specific personal events. This implies we have one system for general knowledge and another, related system for action planning based on personal history and experience.
And current AI mostly lacks this dual temporal system.
That seems to be a major bottleneck. Husserl and McCormack argue that AI's inadequate use of temporal information, operating from a relatively single system, really hampers its cognitive abilities. They identify three specific limitations.
Okay, what's the first one?
Temporal embedding. AI struggles when events are nested within or influenced by other events across time. It tends to treat things as flat sequences.
So understanding that an instruction from last week relates to a deadline next month and impacts today's planning, that's hard for AI.
Very hard. Determining cause and effect across these embedded timescales is a real challenge for current machine learning models.
What's the second limitation?
A restricted perspective on time. AI systems find it difficult to shift temporal frames of reference easily, meaning they struggle to switch between thinking about the past, present, and future flexibly, or relating events across different points in time, which is vital for complex tasks like planning, understanding narratives, or even social interaction.
And they struggle switching between different types of time context, like implied time versus specific dates.
Yes, shifting between an implicit sense of time needed for, say, planning a vacation and an explicit timestamp for a meeting reminder. Humans do this fluidly. For AI, it's often a major hurdle.
Wow. So moving beyond just processing power, true understanding really seems to boil down to these deep issues. Genuine intentionality, rich contextual awareness, and especially the sophisticated handling of time and memory.
It's a much more complex picture than just bigger data sets and faster chips.
Absolutely. This deep dive really shows how much we need these multidisciplinary perspectives, philosophy, cognitive science, psychology, to even frame the right questions about AI's future, let alone find the answers. It's fascinating.
It really is. And that brings us to a final thought, perhaps, for you, our listener. Given what we've discussed, AI's current illusion of understanding, our own tendency to project intention onto it, what new responsibilities does this place on all of us? As users, as developers, as just members of society interacting more and more with these systems, how should this knowledge shape how we interpret AI's actions and, ultimately, how we guide its future development?